In the last video, we set up a transistor device with modifications to the layout. Let's now create a wrapper for this device, then an array of wrappers. Here's a schematic for our wrapper. We have a couple of resistors and capacitors that we'll need to place on the layout. Before we go to layout view, let's quickly note that we set values for width and length. These must be preserved in layout view for this schematic, or we will eventually get parameter mismatches in LVS. Go to Window, Layout to get started. Let's update the differences from schematic. We can now see the components that we haven't placed yet on the layout view. First, let's place the capacitor at the origin. Let's now choose the top resistor from the schematic. Unfortunately, it's not possible to put this exactly on the y-axis with our current snap settings. To have a more precise placement, we can use coordinate entry. If you follow the hotkeys from the introduction videos, this should be mapped to F2. We'll place it absolutely at -22.3 and 17.5. We'll place the second resistor on the origin. The schematic calls for a transistor, but we want to use the updated transistor layout that we made in the previous video. Therefore, we'll press I to open up the component library and place the device. Again, I want to place this at a specific coordinate, so I'll use coordinate entry. We'll place it at 14, 0. We need to connect the bottom resistor to the transistor and the top resistor to the capacitor. We can do this with metal connects. Switch to the metal 1 layer and draw the rectangles by pressing R. With vertex snap-on, you should be able to draw rectangles that fit perfectly. We'll also add a rectangle to the resistor for easier port connection later. Click on the bottom vertex, and using coordinate entry, we can make a perfectly sized rectangle. We'll make the rectangle 4.2 by 4 and use a relative coordinate. Just like we did in the previous video, we need to verify our design with DRC and LVS. Press D for DRC. And note that we have no design rule issues. Let's run LVS. We see we have 2 total issues. The warning can be disregarded because we do not need our pins at this point. The parameter mismatch is an issue with the PDK. It is miscalculating the area of the capacitor. You can safely ignore this error at this point. Here is a schematic of an array of the wrappers that we just made. We want to have 8 copies of the wrapper and have each pin of the wrapper connected to all of the other respective pins on the other copies. Let's start working on the layout. Let's go to the instance library and place a wrapper on the origin. We can quickly make 8 copies of this wrapper spaced evenly apart using array copy and paste, or the A hotkey. We'll have the X spacing be 0, the Y spacing be 35. We'll make 8 rows and 1 column. Note that this is a single instance rather than 8 individual instances of the same wrapper. As a result, you won't be able to modify each component. We'll first connect the emitter ports. We'll do this by creating a rectangle on the vertex snap and drawing up to the top. Your initial drawing does not need to be precise, since you can change the precise values of the rectangle in the Properties window. We want the width to be 8 and the height to be 269.2. We repeat this procedure for the remaining connections that we want. We place the first vertex and adjust the heights, widths, lower x and lower y to fit perfectly. The important thing to note is that we're not creating one-to-one correlated layout in schematic. Instead, we're making sure that all the components are the same and that they are connected the same way. The schematic serves as a starting point for us to ensure that our layout design is working properly, as it is often more difficult to check for connections on a layout than in a schematic. We'll run the same verification steps as before. First, we'll run DRC. We see that there are no errors. Then we'll run LVS. We note that they're the same parameter issue from before. Again, we don't need to worry about this. We have now successfully built an array column of the wrapper devices. This concludes the second part of the RFIC power cell design. Thank you for watching this Keysight ESOF EDA tutorial. You can find a link to a free trial of ADS in the video description below.